This video is for my geometry students. We have a Chapter 9 quest on Thursday or Friday. So here's your review. Anthony Savarati, I hope I do not give you a headache this time with these 10 questions. Alright, first, we are going to translate this figure. So we have a coordinate plane here, and we have a triangle. And the translation says 3, 2. Well, what does that mean? 3 first means right, 3, 2 second means up 2. Okay, X and then Y. So I'll move all my points to the right 3. So this one, 1, 2, and it's off the grid 3, and then up 2. Okay, so that's fine. This point, we'll move 1, 2, 3 to the right and up 2. There's the second point. This point, 1, 2, 3 to the right and up 2. And here is the new figure. And that's a translation of 3 to the right and 2 up. Next. Okay, here we have a blue figure is the translation of a black figure. So we're going black to blue. Okay, so we are going black to blue. And the idea is write the rule that describes this. So this is going to be a translation rule. So we're doing a translation. And again, if you want to be technical, black figure equals blue. And again, the goal is to fill in those two numbers. So what did you do to go from the black to the blue? Well, pick a vertice and just count how you get from the vertex you chose to the corresponding one in the blue figure. Here's my one in the black figure. I go 1 to the right, that's +1, and I go 1 down, that's -1. So what that means, my translation rule is 1 to the right and down 1. And there's my translation rule. It should be the same for all 3 of the vertices in the triangle. 3. We have the points J, A, and G that make triangle JAG. I want you to reflect it over this line, x equals -1. Okay, let's start by graphing J, A, and G. J is at 1, 4. A is at 3, 5. And G is at 2, 1. And I'll put it dotted. And I'm going to reflect it over the line x equals 1. So what I do is I go to where x equals -1. I go to where x is -1. I put a dot. This is going to be a vertical line. So what I do is I count horizontally from each of my vertices to the line. So J is 1, 2 to the left. So I keep going. 1, 2 to the left. There is J prime. A is 1, 2, 3, 4 to the left. Go 1, 2, 3, 4 more to the left. There's A prime. G, 1, 2, 3 to the left. 1, 2, 3 to the left. There's G prime. And there is the reflection. J prime, A prime, and G prime across the line x equals -1. 4. Okay, here we go. We're going to start with the point O. It's the origin. And we're going to do 2 reflections across L1 first and then L2 second. Okay? So L1 is the line x equals -2. So let's go to where x is -2. Right here. And let's draw a vertical line, right? Because that's what x equals -2 is. It's a vertical line. Remember, y equals is a horizontal, x equals is a vertical. And we reflect. To get this point across there, I need to go 1, 2 to the left, so go 1, 2 more to the left. So if this is O, there's O prime. And again, if you want to list out the coordinates, O prime is at the coordinates -4, 0. Okay. It doesn't say list out the coordinates, it just says find the image. That might mean you want the coordinates, that might mean you want this to graph. I'll be specific on the test. If you don't know, just ask a question. And then line 2 is the y-axis. That's easy, that's this one. So to get this O prime to the y-axis, I have to go 1, 2, 3, 4 to the right, so we keep going. 1, 2, 3, 4 to the right. And there's O double prime. And O double prime is at the coordinates of 4, 0. And there you go. There's the image after 2 reflections. Alright, next. Okay, here's the big one. Now again, I'm just going to kind of walk you through it. I really can't show you with a protractor. I don't have that on here. But we're going to rotate this 60 degrees about point P, okay? So let's just go over the steps again, okay? So the first step is connect a point, a vertex, to the center of rotation. So we'll connect A to P. And then we'll measure a 60-degree angle. Now I'm going to assume that a 60-degree angle would be something like that, would be 60 degrees, and you'll put a mark down here. That'll mark where 60 degrees is on your protractor. And then you will measure AP, and then you will line that up here, and you will make a mark the same length as A is away from P along this imaginary line. And I'm going to say there is A prime. Okay? So again, that is a 60-degree angle. And we'll continue on. So again, I'm just freehand drawing it. I'm sorry I don't have a protractor. B. There's P to B. So we're going to rotate 60 degrees. That's about right. I'm going to put a mark down here where the 60 degrees is. P to B is about this far. Make that same length on here. I think it's right around here, actually. It's pretty far. There's my B prime. Okay? And now we'll do a similar thing for D. I'll connect D and P. And again, it gets really messy. I'll rotate 60 degrees about there. I'll make a mark where I think 60 degrees is. I'll measure P to D. I'll rotate it down. It looks like D prime would be somewhere right down here. And the connection of those 3 points, A prime, B prime, and D prime, gives you the rotated figure. It is triangle A prime, B prime, D prime, rotated 60 degrees about point P. Okay, so again, can't be perfect. We practice in class. Again, hopefully, maybe if you need to practice, you got the extra practice in to do this problem. Okay? All right, I think that's probably the toughest question, right? It just requires the most skill with the protractor. All right, there's the first 5. Hope we're doing fine. Second 5, 6 through 10 coming. Here we go. We're going to graph this figure under a 270-degree rotation about the origin. Okay. Well, the first thing we have to make sure we know is we don't do 270, right? This is counterclockwise. And instead of doing 270 counterclockwise, we do 90 clockwise. Okay? And again, clockwise is that way. Okay? So now what I would suggest you do is write the coordinates. So F is at the point 0, 3. G is at the point -4, 1. H is at the point 1, -4. And J is at the point 3, 2. And the first, there's 2 rules, right? The first rule, how many quadrants are you turning? A 90 degrees clockwise is 1 turn, 1 quadrant, which means you need to switch X and Y. So what I will do is I will switch X and Y. So 3, 0, 1, -4, -4, 1, 2, 3. And again, the idea is because it's being turned on its side. Okay? That's what we're doing. We're turning the figure on its side. So X and Y flip-flop. And now we do the coordinates. To get F prime, what coordinate are we going to fall into if we rotate 90 degrees counterclockwise? 90 degrees clockwise. 1 turn clockwise. F is on, oh, sorry, I got to draw something real fast. There's no y-axis. Make sure you draw this in. I apologize, I was interrupted, so it's going to seem like I just jumped. So again, we're looking for now where F prime is located. F prime is going to go from the positive y-axis 90 degrees clockwise to the positive x-axis. Okay? And if it goes to the positive x-axis, then the x must be positive and the y is 0. So F prime is 3, 0. Now, where does G prime end up? Well, right now, G is in the second quadrant. It's going to go into the first quadrant, where X and Y are positive. Make your coordinates positive, positive. H prime is going to end up in the third quadrant. And in the third quadrant, X and Y are negative. So make your X and your Y negative. and J prime will end up in the fourth quadrant, where X is positive and Y is negative. So X is positive and Y is negative. And here are the coordinates of your rotation. Now, we will graph these just to see. So if F is at 3, 0, there's F prime. G is at 1, 4. There's G prime. H prime is at negative 4, negative 1. There's H prime. And J is at 2, negative 3. There's J prime. And if I connect these, hopefully it looks rotated. Right? It does. If I shade it in, maybe I shouldn't have shaded in. Maybe that's... So what I did was I rotated it 90 degrees clockwise, which is the same thing as doing 270 counterclockwise. Okay? So there's number 6. The rotations are tough. Okay, so just practice those. Okay, number 7 here. A freehand draw. We're going to rotate this letter N, and we're going to rotate it, or reflect it, I'm sorry. We're going to reflect it, I apologize. And we're going to reflect it under this composition. Reflection over M, composite with reflection over L. And remember that we go backwards, right? So we're going to do the reflection over L first. So again, however you want to do it, my suggestion might be make these points and reflect the points, or turn your paper sideways. So this point's going to come here, that point about there, that point about there, that point about there, and I believe it's going to look something like, and again, might be a little bit off, something like that. Yeah, that's pretty good. Okay, so there's my N that got reflected over line L. Okay, and now I'm going to reflect over line M. Remember, go backwards. So again, here are my 4 points. I'll reflect, so this point comes here. This point goes somewhere over there. This point is somewhere here, and that point is somewhere there. And again, you'll see that it's a little bit bigger, but hey, I'm cool with that. That looks pretty good to me. Okay? So we see that this did not translate, but this rotated. So it's a rotation. Okay, so you see the question says, for translation, describe the direction and distance for rotation, tell the center and angle. Well, the center is the point where these two lines intersect, and that'd be C. That's this point right here. And the angle is going to be 2 times the acute angle between these two lines. That's 2 times 75. And that's going to be 150 degrees. And you see that this figure almost went all the way around, which would be 180, right? If you, well, for the letter N, if you spin it 180 degrees, it's like it's going to come onto itself. So anyway, so that's almost 180 degrees. That's a 150 turn. And if you connect, let's say this point to the center, to that point, those are corresponding points. That angle is the 150 degree angle that you rotated. Okay. So be aware of these reflections over 2 lines. It's 2 of your note cards. Make sure you do those well. All right. Okay, next. We have a glide reflection problem. Here we go. So this is a glide reflection. We have this graph here, and we have this reflection. It's a reflection and a translation. Now we're going to go backwards. So we're going to translate first. This means move in the X nowhere, and we go down 3. So take all of your points and move down 3. So B, 1, 2, 3. Well, that doesn't make sense, right? Why didn't they give me enough graph? Okay, so we're down here. That's B prime. N, 1, 2, 3. There's N prime. P, 1, 2, 3. There's P prime. And there's the second figure. That's the intermediate figure. Okay? And now we're going to reflect over this line X equals 0. This is the second one. And X equals 0, go to where X is 0. That's the origin, and it's going to be a vertical line. So you can see why this is a glide reflection. I'll extend that blue line down further because of B. You can see why it's a glide reflection because we went up and down with our slide, and now we're going to reflect over a vertical line. And again, we just count. So B prime is 1 away, so come over here. There's B double prime. N prime is 1, 2, 3 away, so go 1, 2, 3 away. There's N double prime. P prime is 1, 2 away, so go 1, 2. There's P double prime. And again, I'm sorry it's hard to see, but there is your double prime figure, the final image after this glide reflection. Okay. Again, do not be confused that the image, the triangle, is partly on the left and right side of that vertical line. If you reflect, simply things on the left go to the right and things on the right go to the left. It's no big deal. Okay, so don't worry about that. Okay, and now we're in dilation territory. Number 9 here. It says the blue figure is the dilation of the black figure. The labeled point is the center of dilation, and that would be center right here. This is O. Tell whether the dilation is an enlargement and a reduction. Find the scale factor. So we are trying to find dilation, scale factor, about the origin of the black figure to the blue. That's what we're trying to do. Okay? So, if we see the black is smaller than the blue, that means we're getting bigger, so this is going to be an enlargement. So we are enlarging, okay? And now we need to find the scale factor. And to find the scale factor, you can use the length from the center of dilation to a pair of corresponding vertices, or you can use the length of 2 corresponding sides in the 2 figures. In this one, the distances here and here are vertical and horizontal, so we can use these 2 lengths. So the scale factor n is our new over our old. So we're going from O to the blue. So let's do the vertical one because I can write it easier. So from this point O to this point right here on the new figure, how many do we go? 1, 2, 3. From this point O to the corresponding point of the old figure, how many do we go? 1, 2. There's your scale factor. 3/2 or divide it 1.5. Okay, so you use a pair of corresponding lengths, whether it's from the center of dilation or it's just a pair of corresponding sides. That's how you find the scale factor. New over old. Okay, last one here. All right, we have this picture. And again, I saw this when I made it. This is missing a y-axis. Make sure you fill that y-axis in as best you can. That's pretty bad. Okay, so the idea is we are going to dilate this picture of QRTW, center of 0, 0, and a scale factor of 1/4. Okay, so remember, if the center of dilation is the origin, it is as simple as taking your scale factor times your x and your scale factor times your y. So if I'm looking for the primes, first I will list out the coordinates of Q, R, T, and W. So Q is at the point -3, 4. So then Q prime is going to be at the point that is 1/4 of these. 1/4 times -3 is -3/4. 1/4 times 4 is 1. Let's go with R. R is at the point -2, -1. R prime will be at the point that is 1/4. Maybe I should put that right here. Let me put that right here. We're going to do 1/4 x, 1/4 y. So I take 1/4 of -2, I get -1/2. I take 1/4 of -1, I get -1/4. There's R prime. I continue on to T. T is at the point 3, 1. So I take 1/4 of 3, that's 3/4. 1/4 of 1, that's 1/4. There's T prime. And then finally W. W is at the point 3, 5. I take 1/4 of 3, which is 3/4. I take 1/4 of 5, which is 5/4. And again, if you want to use decimals, that's fine. But here are the coordinates of your new figure. So now we're going to graph that, and I'll do it here in blue. So Q prime is at -3/4, 1. So -3/4, 1. r prime is at negative a half, negative a fourth. Negative a half. There's r prime. T prime is at 3/4, 1/4. And w prime is at 3/4, 5/4. That's 1 1/4. And here is the new figure. It got 1/4 as big. It shrunk towards the origin. Okay? And there are the coordinates. Now, just to, again, emphasize this idea. The origin is O. If I connect O to Q prime, it should go directly through Q as well. And that's pretty darn close. Okay? So again, your center of dilation, your pre-image, and your image should all be on the same segment. Okay? But in the coordinate plane, it's as simple as taking the scale factor times your original coordinates. Okay? Alright, so again, hope this gave no one a headache. Hope you guys enjoyed the 10 problems, and you're going to do very well on your quest coming up on Thursday or Friday. Happy studying, and we'll see you then.